Okay, and welcome to week 3. And this is desktop publishing, of course. And we're going to basically review charts and graphs for you. And the reason why we're doing that is because I really want to make sure that you have the ability to use these things if you want to. If you haven't considered using them, I think you should consider them now because some of the presentations I've been seeing coming in might benefit from them, especially if you're talking about real data, real figures, and you want to actually make a point that's understandable. So charts and graphs. Okay, so here we are, charts and graphs, desktop publishing. So why do we use them? Well, the simple reason is that they convey information. Information is key. The reason why you're doing a presentation is to convey information. Most corporate communication projects require the dispensing of complex information. That is literally what your job is. Corporations are communicating. They're communicating complex things. They want everybody to be on the same page. They want everybody to understand what they're talking about. And they want everybody operating with the most current facts. Charts and graphs allow you to communicate the meaning of information very quickly than just the data itself. If you send everybody a mass email showing all of the figures, half the people are not going to be able to understand them no matter what you do. If you just give somebody a column of numbers, there are some geniuses that can look at that and basically spit out a concept, but most of us will just glance at it and say, well, I don't know what this is. So a chart puts it all in some kind of context, and that can be actionable. It can show you, show you warning signs. It can show you reasons that you would want to change what you're doing. And so that's why we're doing this. Charts and graphs are an interpretation of data. And more importantly, you may be required to make those interpretations. They may just give you the data and you're supposed to figure out what it means. And hopefully you'll have some help. But the fact is, when you enter the data itself, the answer may speak for itself. That's the beauty of it. Okay, types of charts. And again, this won't be a very long presentation. The pie chart it's got a place. It's designed to talk about populations as a whole and percentages of a population. The bar chart more or less shows you comparisons between different things. The line graph talks about trends, and the scatter plot deals with averages and allows you to establish behavior, trends, and patterns. And between those four, that really covers the basics. There, if you look at PowerPoint and you look at the chart creation engine, you will see a whole host of different types of charts, most of which fall into one of those four categories, and some of them are just plain bizarro that basically nobody can understand until you teach them how to do them in the first place. So for that reason, I don't choose to go into those. Okay, each type of chart has a specific purpose or use. And the simplest type of chart is always the best. You see some that have all these 3D stuff in them, these incredible animations that go with them. Don't be confused by those. Don't be taken in by that. Always go with the simplest and most accurate. If a chart cannot be understood, there is no point in using it. If somebody can look at a chart and doesn't know what it means, if the average person can't, then you know that most people can't. And I believe it was General Lee who said, or his idea was, if you wanted to see how easy it was to understand an order, he would find the dumbest person he could and read them the order. And if they could understand it, then he would know that the order was good. And so let's say we apply that to this. If you can't understand the chart, your audience isn't going to understand the chart. If the chart by its nature distorts the meaning of the data, it's actually doing harm. If the chart looks like it's saying something that the data doesn't convey, then it's hurting you. It's not helping you. Okay, the pie chart. Let's talk about that in detail. The pie chart analyzes a whole. It assumes that the data is a closed universe, that you have a cap, that there's only a certain number of people that you're talking about or a certain number of things, and whatever that is, it is. And so whatever percentage of that chart is, it cannot go over 100%. You can't have more or less than 100%. So meaning that you can't talk about you can talk about zero, but whatever your data is based on, it's based on the full number of the people surveyed, or whatever it is. It does not mean that you need to know that exact number. The computer will figure it out. That's why we use them. and you don't need to calculate your own percentages. Again, that's what computers are for. Okay, so here we are in our wonderful little PowerPoint program, and I am just going to create a slide, and we're going to do this quick and dirty. Now I'm just going to call this pie chart. That will be the slide title here. And if I look down here, here is my little cornucopia. I am just going to go ahead and select Insert Chart, and there I've got all kinds of possibilities here. And I'm just going to grab pie, and you can see there's a few different variations of that. I can do a 3D pie. I'm not going to do a 3D pie, even though I think it looks cool. I also wouldn't do something like this because I don't know why you would. That's just confusing. And so this may look cool, but if you examine the way they've done this, the blue area looks bigger than it actually is, only because it's got this extra edge, whereas the gold area looks smaller than it's supposed to be because it has less of it doesn't have that third dimension there because it's over there. This, on the other hand, is the most accurate. This will show you the data in the most accurate fashion possible. So we're just going to hit OK, and then we're going to get our chart. So this is the chart. It already builds it for you, puts it on the slide, and then here you have this window into which you can import information. I'm just going to park this over here. And so it's already giving you this legend that you can add to or take away from. So for example, the word sales shows up here. And so we can work with that. And so we can say that we're not really doing sales. We're talking about, let's say we change that. I double click on that. And I'm just going to call that, let's say, country of origin. So let's say we're talking about a population of students or employees or what have you. And so now here we have, down here we have first quarter, second quarter, whatever. So let's say we just put countries in there instead. So in the first quarter, I'm going to change that to USA. And let's say my second quarter, instead of doing second quarter, I'm going to put in UK for the United Kingdom. And let's say here, I'm going to say EU for mainland Europe, let's say. Or down here, I can say Asia. And I can even add some that aren't even there yet. So let's say that I have one for South America. And let's say I've got, let's say I've got Eastern Europe. And let's see one other. Let's say we go a little bit crazy and we'll say Antarctica. All right, so, and let's say that there could potentially be other countries, but those are the countries that we know are going to be represented in our whole. So let's say under US. Now right now, under the US, if you look there, we have 8.2 people. And so chances are that's not correct. So let's say if we look at our country or our company as a whole, let's say we have 4,000 people that we know are from the US. So if I accept that data, immediately this chart goes nuts because it was originally calibrated in very different units. So the computer's done the math, and it's basically saying we've got 4,000, that's going to be some massive percentage, and the UK with 3.2 people is barely even visible there. So let's say instead of 3.2 people in the UK, we will change that figure to say 300. So if I do that, let's say we have 300 people who are specifically from England. That percentage now begins to make a little bit more sense. And let's say we have more people from mainland Europe. Let's say we'll put that at 600, but it's still, let's say, an American country. But surprisingly enough, maybe we have 2,000 people who work in Asia, whether it's India, China, so forth. And let's say we have a relatively small percentage of people from South America. Let's make that 600. And Eastern Europe, let's say, for some reason, let's make that another 1,000, let's say. And from Antarctica, let's say we've got 50 people. And so that gives us this. So we have our legend, we've got our colors there, and so that creates this chart. And if we're happy with that, we can close off our data, and we've got our pie chart. And so we didn't have to do any math to do that. Let's say I'm handed a stack of figures. All I did was put those figures into the program, and it generated the chart. And so then we can decide how we want to display that data. So for example, if I were to click on this and go to my data labels, you can see I can turn on the data labels. So those are my actual numbers. And I can go on from there. Okay, the bar chart. What does the bar chart do? The bar chart compares entities. And so these could be almost anything you can think of. Let's say you have runners in a race, how many miles a particular runner ran, how many sales a particular person did, how much poundage did somebody lift, all those different things. And the bar compares the performance of one or more party in a certain context. This does not necessarily mean that all circumstances are equal. So, for example, maybe somebody did more sales than somebody else, but it could be that the number of customers available to that person was much larger. So it doesn't necessarily include all the necessary information, as most data does. You may have to consider more than one factor, and if you were the one compiling this and you didn't want to mislead people, you may have to mention that. Okay, and unlike the pie chart, there is no maximum possible value. And so, if you continue to stack this information onto itself, you can have someone with an abnormally large percentage of this. And that's just the way it is. Because if they can find more customers to add, then it could be that it changes the nature of the data, which you will see. And the chart automatically adjusts to scale. And so we're over here. Let's say I go to home and I add a nice new slide here. And this one is going to be, I'm just going to call it bar chart. And there, I go to my little cornucopia there. And I'm just going to find a nice bar chart. And in this particular case, let's see if there's... And in this particular case, the column chart really works to be about the same. So let's go with that, because they're both bars. They're basically doing the same thing. They're just going different directions. And again, I could possibly choose different types of bars, strike bars, plain bars, and stuff like that. So I'm just going to go with the simple one because it's probably the best way to go. So if I hit OK, then I get this wonderful bar. Now notice I've got a series of categories here. And so we could use those or we could not use those. I'm going to go ahead and say that we don't necessarily need to. So I'm going to move this down here. So what I'm going to do is I'm going to go over here and I'm going to say that we have all this data in category 1 to 3. So let's say I go to category 2, right-hand click. I'm just going to delete the entire row. And when that happens, the chart loses a row. So I'm just going to basically delete these two other rows too, because I would prefer to keep this nice and simple. So category 4, we'll get rid of that too. And if you feel the need to put something like that in, you can. So let's say we're only comparing 3 different pieces of data. And so let's say instead of series 1, I'm going to call this Frank. So let's say Frank is being measured for something. Let's say that this has to do with sales, and we'll call this Beverly. And we'll call this, let's say we call this Scott. So now, look down here. We got Frank is blue, Beverly is orange, and Scott is gray. And so let's say that we're building this chart, and Frank has sold, say, 4,000 widgets, whatever widgets are. The moment that happens, Frank's sales figures go through the roof, and you really can't see anybody else's because Beverly has 2.4, which isn't even a whole number, and Scott only has 2. So let's say Beverly does, let's say, 5,000. Or let's make it sound more realistic. Let's say 5753. So some not so round number. And let's say Scott really did have a bad day, and he only did, let's say, 7,800. That's 780, let's say. So that would still put him on the map. And so then, if that's as far as we take this, let's say we look at this chart, and we can see who is doing most of the work. It works out that Beverly happens to be in the lead. Now, that doesn't necessarily mean, again, that all of the possibilities are the same there, but that's how it is. And you could have 40 salespeople, and this would help you pick out the best ones. Now, for the line graph identifies trends, because there you have a line that changes over time. It goes up and down like a little elastic band, and ultimately, the different data points indicate readings at different points in time, which tell, based on the relationship between them, what's happening. Now, there is no guarantee that these trends will continue as expected, but they usually will. The assumption is that they will. There's also no absolute proof that the areas between the data points match the line, meaning that you could have something that takes a sudden drastic dip way the heck down and comes back up the next day. You never know. But ideally, that shouldn't make all that much of a difference anyway. So the data, the little points, like if you're measuring sales per second, let's say, you may not get any sales 1 second. You may get loads of sales another second. But if you're measuring it by the hour, that may make more sense. Okay, there's also no guarantee that the trend takes into account the distant past or future plans, meaning that this trend may not hold if you're about to do something very different with your company. And also, if you're trying to, or if somebody's trying to mislead your people, they may simply show this month as if it's in some kind of an alternate universe than the last 20 years. Okay, so here let's add another slide. And I'm just going to call this line graph. I'm going to add one of these, and we'll just grab a simple one. So let's say we look at that, and we say OK. And so that is our chart. And for this particular situation, I am just going to do one element that we're measuring here. I'm going to make it as simple as possible, so that means I'm going to get rid of 2 columns. So that means we've only got one trend that we're going to talk about. And so that is going to be, I'm just going to call this revenue. And we've got 4 units here. And we'll just call that, say, 1990, 2000, 2010, and 2020. So let's say this is a thumbnail sketch of revenue over the past 20 years, I guess. That would be longer than 20 years. Over the past 30 years, I guess. So let's say we start at 4.3 million, and let's say instead of a downward trend, let's say we go up a bit. So let's say we go 5.6. So you see now the trend is going up, and then let's say we start coming down again. Let's say we don't take quite as big a hit, so let's say instead of 3.5, we go to 4.9. And you see how you can modify that curve. And let's say 2020 is a little bit better. Let's say we're up to 5.7. So if we do that, then we could get some sort of a chart like this. And so these are millions of dollars, let's say. So we're going to cut that off. And so looking at this graph, and you can basically describe it as a revenue history over time, and there's an overall upward trend. And so that is what you would want to do. Okay, so the scatter plot is going to be one of the least used things that you're likely to find. You don't usually have a cause to use this, but you can. Scatter plot simply displays data points. And the data points are all independent. And basically, the cloud created by the data points indicates commonalities. And this can approximate mean values or average performance. These are outside, those things outside the cloud are not typical for one reason or another. So if we were to try to make one of these, so we go home here and add one more slide, we'll call this scatter plot, and down here, and let's see what we got for scatter plot. Now this, I am not going to do a whole lot here. I'm just going to call it up. We have X and Y values, and you would have to put a lot of values in here to have it begin to make sense. Now to understand this, let's look at it in a different context. Let's say you've got a target display and you are shooting arrows at a target. And let's say that the bullseye is right here in the center. And let's say you've got one shot up here, one shot down here, one shot down here, one shot up here. That would indicate that the average is somewhere in the center. So that's where the cloud would wind up. On the other hand, if you've got nothing over here and everything over here, then the average moves from the center to the edge. So that's really what you're thinking about. So to use a scatter plot, the more data you have, the more sense it makes. This just allows you to establish some kind of an average. And so if you've got a scatter plot with only, looks like only 3 points on it, there really isn't much you can say about it. But if you have, say, several thousand, then you can say a lot more. And so I have an animation here which demonstrates a way of thinking about this. This is an example of the bell-shaped curve where you throw in a lot of random data points and see where they land. And the idea is, in theory, they could go all the way to either end. But ideally, what should happen is that most of them should wind up in roughly the middle. And so this demonstrates kind of what the bell-shaped curve would look like. You can see it kind of there on the bottom. So that's the kind of data that we're talking about. And so here we are. This is the basics of charts and graphs. And it's not an exhaustive lecture, but it's a general understanding of what the chart and graph should be. And occasionally you'll find that this enhances your presentation.